Have you ever wondered if what's happening right now, far across the universe, is the same for everyone? Or, could two people standing side by side on Earth actually disagree about what's happening now in a galaxy, millions of light years away? Let's dive into one of the coolest, strangest, and most mind-bending thought experiments in physics, the Andromeda Paradox. This idea was proposed by Roger Penrose, and it's all about how Einstein's theory of special relativity messes with our sense of now. I promise this isn't science fiction, it's real physics. So here's the setup. Imagine two people, Alice and Bob, walking past each other on the street. Alice is walking toward the Andromeda Galaxy. Bob is strolling away from it. They're both moving really slowly, let's say just a few meters per second. When they cross paths, they synchronize their watches. Seems simple enough, right? But here's where things get wild. According to special relativity, time and space aren't separate, they're linked in what's called spacetime. And there's no absolute present. What one person calls now might be different for someone else, even if they're standing right next to each other. Because Alice and Bob are moving in different directions, their planes of simultaneity, what they each consider to be happening at this exact moment in Andromeda, are actually tilted just a tiny bit. Sure, they're only walking, but the Andromeda Galaxy is about 2.5 million light-years away. That huge distance magnifies even a tiny difference in their speeds. So, let's say there's an alien council in Andromeda right now, debating whether to invade Earth. According to Alice, who's walking toward Andromeda, the council has already voted. Bob, walking away, thinks the council hasn't decided yet. They're both still standing on the same sidewalk. How is this possible? It all comes down to the math of special relativity. There's something called the Lorentz transformation, and it tells us how time coordinates shift for moving observers. The key formula is T equals gamma times T minus V times x over c squared. Here, V is the relative velocity between Alice and Bob, x is the distance to Andromeda, and c is the speed of light. Because x is so enormous, even a tiny v creates a noticeable shift in what each considers to be now in Andromeda. It could be days, even years apart. But, and this is crucial, Alice and Bob won't see the aliens acting differently. Both will still have to wait 2.5 million years for light from Andromeda to reach Earth. The paradox isn't about what they can observe, it's about how they theoretically assign the concept of now in the distant galaxy. So what's the big takeaway? The Andromeda Paradox isn't a contradiction or a true paradox, it just shows how weird and counterintuitive relativity can be. Now at a distant location isn't universal. Even tiny movements on Earth shift what's considered present in far-off galaxies, simply because the universe is so vast. But don't worry, this doesn't mean we can send messages faster than light or break causality. Information is still limited by the speed of light. The Andromeda Paradox is a striking reminder time isn't absolute. Simultaneity depends on how you're moving through space. Even your slow walk on Earth can lead to different interpretations of what's happening right now, millions of light years away. Mind blown yet? That's the universe for you.